Solve 2r to the 2/5 plus 5r to the 1/5 equals 3. The first thing we need to do is get all the terms on the same side of the equation. So we're going to start by subtracting 3 on both sides. This gives us 2r to the 2/5 plus 5r to the 1/5 minus 3 equals 0. And now we want to get this in quadratic form. So we want to write this as 2 times something squared plus 5 times something minus 3 equals 0. And so we need to ask ourselves, what quantity can we square to end up with r to the 2/5? And that quantity is r to the 1/5. Again, when we have a situation with an exponent on top of an exponent, we know that those exponents multiply, and 1/5 times 2 gives us 2/5. And then the same thing works out here. If we put r to the 1/5 in here, 5 times r to the 1/5 is 5r to the 1/5. So we know that the quantity we need in the parentheses is r to the 1/5, and that means that the z substitution we're going to make is we're going to let z be r to the 1/5. When we make that substitution, this gives us 2z squared plus 5z minus 3 equals 0. And we can factor this using the AC method. Here, a times c is -6 and b is 5. We need two numbers that have a product of -6 and a sum of 5. Those numbers are 6 and -1. So we can use those numbers to split the middle term, which gives us 2z squared plus 6z minus 1z minus 3 equals 0. We can finish by factoring by grouping. The first group becomes 2z times z plus 3. And in the second group, we can pull out a -1 to leave us with z plus 3. So we have 2z times z plus 3 minus 1 times z plus 3 equals 0. The two groups have a z plus 3 in common, so that's the GCF for the problem. And that leaves us with leftovers 2x minus 1. So we have z plus 3 times 2z minus 1 equals 0. We can use the zero factor property now to set each of those equal to 0 and solve. So we have z plus 3 equals 0, or 2z minus 1 equals 0. If we solve these, we end up with z equals -3. And then for the other equation, if we add 1 to both sides, that gives us 2z equals 1. And if we divide by 2, that gives us z equals 1/2. So we have z equals -3, or z equals 1/2. I'm going to rewrite these over here so we have more room to work with them. Now, our goal wasn't to solve for z. Our goal is to solve for r, the variable in the original equation. So we need to make our substitution again, but the other way, wherever we see a z, we should replace it with r to the 1/5. So here that becomes r to the 1/5 equals -3, or r to the 1/5 equals 1/2. Raising something to the 1/5 power is the same as taking the 5th root. So this is the 5th root of r equals -3, or the 5th root of r equals 1/2. And if we want to get r alone in either of these equations, we have to raise both sides to the 5th power. In this first equation, when we take the 5th root of r and raise it to the 5th power, the root and the power cancel out and we're left with r. On the right-hand side, -3 to the 5th is -3 times -3 times -3 times -3 times -3, which is -243. So that is our first solution. For the second solution, again, we need to raise both sides to the 5th power. When we do that, the 5th root of r raised to the 5th power is just r. And 1/2 to the 5th power is 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is 1/32. And so the solutions to this equation are r equals negative 243, or r equals 1/32. And that is our final answer.